Good. So we continue then with 11.3. Solving equation. What am I doing? Solving equations that are quadratic in form. Solving equations quadratic in form. Solving equations that are quadratic in form. And they are on page, and I'll let you choose, and I'll choose. Allow me to choose the first two, and then you choose the next two. So we are on page 678, and I'm looking at anything from 1 through 58. However, we cannot solve the ones that are part of Chapter 7 because we haven't covered Chapter 7 yet. So it's not everything. It's most of them, but not rational equations. Okay, so let's start by choosing, let's say, 17. In 17 we have, I'm going to use x instead of z. So x to the fourth minus 13x squared plus 36 equals 0. Okay. This is an equation that has degree, the polynomial in this equation has degree, say it again. Very good, excellent. So I expect to see how many solutions. 4 solutions, very good. Real, imaginary, even if they're all the same, I have to present 4 solutions. Good. Now, I see that the degree is 4, but degree 3 is missing, degree 1 is missing. So something comes to my mind and I would say, okay, what if I denote this by t? Now, I can have x and t in the same problem. So will this one be t squared? Because if it's not, then I can continue on this path. So if I square x squared, do I get x to the fourth? So then I can change this equation using the substitution t equals x squared. I can change it into t squared minus 13t plus 36 equals 0. And this is familiar territory because I know how to factor this. That might be a little bit more difficult. Some of you may say, I don't really need this. I know how to factor this directly. That's fine. If you do, I'm happy. Do it. Okay? But I think it's easier if we use a substitution. So now this is a polynomial in descending order, no greatest common factor, no negative leading coefficient, no special product. 1 is the leading coefficient. So I should be able to factor it quickly. How do I factor it? That's it. So there are 2 solutions for t, or in t if you want. And you could say, but who cares about t? Yes, we do. Nobody else. The solution has still to be presented in terms of x. Okay, so then how much is t from this equation? 9 and 4. Now, what does this equation really mean? Exactly. Equals 9. And what does this equation really mean? Good. I'm expecting 4 solutions. So how do I solve the equation x squared equals 9, and then later on x squared equals 4? Yes, this is a typical situation for square root. But if I forget something very important, I will not get 4 solutions. What am I referring to? Yes. And then here the same thing, x equals plus or minus 2. So I got all 4 solutions. Questions? Okay, 33. P plus 2, everything squared, equals 9 times p plus 2 and minus 20. And you could say, what is this? I can square p plus 2. I can distribute, multiply, and move everything to one side. It's quadratic. I'm going to set it equal to 0, blah, blah, blah. I agree. But let's practice what we are discussing here. I'm looking at p plus 2 squared, and I'm looking at p plus 2, and I'll say, oh, they're the same. This one could be denoted by whatever you want, not p. And this one then will be, that's it. And then I'll come back. So basically I said let y be p plus 2. So then the equation is y squared minus 9y plus 20 equals 0. Because it became quadratic. It was quadratic. This particular one was quadratic all the time from the get-go. So, and I have to set equal to 0. I have to move 9y, and I have to move negative 20 to the other side. But this is not such a big deal. It's in descending order, no greatest common factor, no negative leading coefficient, no special product, but luckily 1 is the leading coefficient, so I will not have a tremendous amount of work. The product is, and the sum is. Since the product is positive, I expect to either positive or both negative, but since the sum is negative, I expect two negatives. And since the leading coefficient is 1, I go directly to factor. I don't need a long procedure. So that would be y minus and y minus 5. So then from here I have two solutions in y. One of them is, and the other one, perfect. But I know that this is basically the equation what? Equals 4, and the other one is p plus 2 equals 5. So therefore p equals and p equals. I would say it's a very elegant method. You can remember it as the method of substitution, or you can remember it as solving equations quadratic in form. It's up to you. So I know the answer here is, and the answer here is 3. I think you would have taken maybe the same amount of time, slightly more maybe, to square this, distribute, move those terms instead of this. The same thing, pretty much. Okay, so let's look at, let's say 20. So x to 2/3 plus 2x to 1/3 plus 1 equals 0. And if you look at this problem carefully, you'll say, oops, this looks awful. Not really. If you think of it, or if you look at it in terms of, oh, if I denote this with the smallest coefficient t, will this be t squared? If it's not, I cannot continue on this path. But if I square x to 1/3, I copy the base, and I might multiply the exponents. 1/3 times 2/1 is 2/3. So this is indeed t squared. So if I denote this by t, this is definitely t squared. So I'm going to say let t be x to 1/3. How do I proceed? Do t plus 1 equals 0. Descending order, greatest common factor none, negative leading coefficient no, special product. I always hope for one, because it's always the easiest. So is there a special product here? Yes, this is a perfect square, this is a perfect square. So then, by the contract we have, we should think of t plus 1. Let's check the middle term. 2 times the first times the second is 2t. Now this has two solutions. And you will remember this hopefully in the next course, when you will see how important a double solution is. This is a double solution. Same thing twice. And you will see what that means. So t equals perfect. But now what equation is this? I still have one more equation to solve. And what equation is this? And is there another way of writing x to 1/3? Very good. What type of equation is this? Chapter 10. We can't forget chapter 10. It just ended last week. Very good. Excellent. It's a radical equation. How do I solve a radical equation? Yes, principle of powers, I cube both sides. The left-hand side is, the right-hand side is, although the power is odd and I know it's going to work, I still have a question, right? Every time we use this principle that is not a basic principle, I may get or run into solutions that are not working in the original problem. I have to go back and check. Although I told you a little trick, when the power is odd, it will work. When the power is even, that I use to raise both sides to, I may run into solutions that do not work in the original problem. So -1 to 2/3 plus 2 times -1 to 1/3 and plus 1. -1 squared is 1 and the cube root is 1. But the cube root of -1 is -1. Does this equal 0? So I will say yes. And now these are the only types that we can go over. So let me know if you would like to choose another problem of any of these. Say it again. 51. Let's look at 51. Yes, but it's not what I'm looking for, but we can work on 51. 51 is not of the type that we just looked at. But since you mentioned 51, let's work on 51. So in 51 we have x plus 3 times x squared minus 3x plus 9 equals 0. How many solutions will come from the first factor? Exactly. How many? 1. How many will come from this factor? 2. So how many solutions I have to present? Yes. Even if they're imaginary or not, whatever, I have to come up with 3 solutions. Perfect. So first solution is clear. Correct. The second one I have to work on. The other two, the second or the third. Don't try to factor. This isn't factorable. So my only chance is the quadratic formula. -b plus or minus b squared. And you cannot start with a negative number here. Exactly. Minus 4 times a, which is 1, times c, which is 9, over 2 times a. So one more time, -b. Let me write the quadratic formula here. -b plus or minus the square root of b squared minus 4ac over 2a. Square root of b squared minus 4 times a times c over 2a. So this is what I would have done under the square root. I would have written this instead of multiplying and subtracting. I would have factored out a 9 and 1 minus 4 in parentheses, because I have to simplify it anyway, and I have to take the 3 outside. This is what I would have done. So then x equals 3 plus or minus 3, and this is the square root of -3. Instead of saying 9 minus 36 and then come back with to -27 and then have to split into 9 and 3 and -1, I would have factored. But it's the same thing. Whatever the method you are using, it's the same. I would like to choose one more and then move on. Let's say 56. 56 doesn't look friendly at all. 8 x to the fourth plus 14 x squared equals negative 5. Doesn't look friendly at all. Can anyone tell us or walk us through the steps? What would you do here for this problem? So you cannot take the square root. We cannot take a square root from a sum. I know it's tempting, right? You may think that you can take the square root from, no, you cannot do that. Yes. So let's say this is t. But only if this is t squared. Otherwise, I have to find a different method. If this with the smallest power is denoted by t, and the one with the larger power is denoted by t squared, I have to make sure that it works. So is x squared squared x to the fourth? Yes. So now the equation is 8t squared plus 14t plus 5 equals 0. Which is the most difficult type of trinomial? It's not a special product. There is no greatest common factor, and 1 is not the leading coefficient. There's nothing I can simplify, nothing I can do anything, nothing here. So then I have to find two numbers whose product is, yes, excellent. I have to involve the 8. Perfect. And whose sum is 14. Now, all of a sudden, it becomes a little bit easier. It's not a big number, and I can easily figure it out. But remember, the numbers we come up with right now will not be the numbers that will give us the factored form. They will give us just an intermediate step. So what is the intermediate step? Yes? 10n. Very good. Plus 10t plus 4t plus 5 equals 0. Excellent. And now from the first two terms, I will factor out very good 2t, and I have in parentheses 4t plus 5. What do I have to get from the other two? 4t plus 5. And I need sign and number, or sign and factor. So then I have 4t plus 5, 2t plus 1. So I finally have two solutions in t. And I get t equals negative 5 over 4 and negative 1 over 2. Well, but it's not done, right? If you remember, we said let t be x squared. So then we have two more equations to solve. X squared equals negative 5 over 4. And x squared equals negative 1/2. It is clear which method I'm going to use, and it's also clear how many solutions I will get. I should have asked that from the beginning. And it's also clear what type of solutions I will get. What type of solutions will I get? Both. All four. Yes, both equations will give us imaginary solutions. And the method must be this. So then x equals plus or minus I the square root of 5 over 2, and x equals plus or minus I over the square root of 2, but I need to rationalize, as we know from the previous chapter. So then x equals plus or minus I the square root of 2 over 2. And we got our four solutions. Any questions? Any questions? 11.4 deals with non-linear inequalities. Non-linear. I would like to list the types of inequalities we know so far. Number one, we know linear. Something like, let's say, 2x minus 4 less than or equal to 3. We know absolute value, like x minus 1 greater than or equal to 9, or 2x minus 3 less than or equal to 11. We also know compound inequalities, something like x minus 4 less than or equal to 0, or x minus 3 greater than or equal to 4. Compound inequalities. We're going to look at two more now, quadratic and polynomial. Polynomial means, you can say, but linear is polynomial. Quadratic is polynomial. True. Higher degree than 2. We call polynomial. We call them polynomial. So you cannot try to borrow any of these methods here. You cannot separate. You cannot use the concepts that we learned here. There is nothing like this. So these are totally different types of inequalities. I'm going to start with a problem like, let's say, number 5 on page 687. Let's say x squared minus 7x plus 10 less than or equal to 0. This is a quadratic inequality because the polynomial on the left-hand side has degree 2. So it's not linear, it's not absolute value, it's not compound inequality, it's quadratic. So here are the steps for a quadratic inequality. I have to have 0 on one side. Like solving equations, unless I take the square root. Unless I take the square root from both sides. Sorry, it's right here. Unless I take the square root from both sides, when I solve a quadratic equation, I always have to have 0 on one side. Quadratic formula, factoring, completing the square, everything except taking square roots. So the same thing here. Okay? I have to have 0 on one side. So step number 1, 0 on one side. Step number 2, factor the other side, the polynomial on the other side, or the quadratic polynomial on the other side. Okay. Not sure what I wanted to write here. Good. Okay, can anyone give us the factored form of the left-hand side? Excellent. In step 3, I will study the sign of x minus 2 times x minus 5. When you read the book, if you find a method that is better for you, please use it. I like my chart. I don't take credit for it. I was taught this way. So, and I enjoy it. I enjoy to present this very much. So, but you may say, meh, too much writing and I don't like it. That's fine too. I agree with it. Okay, So in this chart, I'm going to study the sign of this expression, of this product. So I have to be, this has to be a product, otherwise the chart will not work. Okay. X is the variable in the problem. It can go from negative infinity to infinity. The next row, I have the first factor. In the next row, I will have the second factor. And all factors will be in one particular row. And of course, what I'm interested in will be the last row, which is the product. I don't care for x minus 2. I don't care for x minus 5. I care for x minus 2 times x minus 5. In order to study the sign one more time, I have to have 0 on one side, and I have to have a product on the other. Both conditions are fulfilled. Now, I need to ask myself, for which x value is x minus 2 0? X minus 2 will be 0 when x is 2. For this one, x minus 5 will be 0 for x equals 5. These numbers have to be put in the x values in ascending order. So I have 2 and 5. 2 is first, 5 is second. Then I'm asking myself next, in this row, there must be a 0 somewhere. Under which number? I know it's silly. Under which number I have a 0 for x minus 2? Of course. Under which number I have a 0 for x minus 5? Now, when x is 2, what happens to the product? Right under 2, I have to write something in the row for the product. What will I write? Of course, because if any of the factors is 0, the product must be 0. Again, what do I write under 5? Good. So I have, at this point, I have several ways. Number one, for this x minus 2, before it's 0, I plug in a number and study and put the sign in here. Then after 0, I plug in a number and put the sign. That's one option. So please plug in a number between these two, between negative infinity and it's 0, and tell me the sign. Don't calculate anything, I just want the sign. Negative, of course. If you plug in negative 10 minus 2 is negative 12. Now please plug in a number on the other side of the 0 and tell me the sign of x minus 2. Plug in 10. Repeat the same process for x minus 5. What do we get before it's 0? Yes. What do we get after it's 0? Instead, here's the second way. How will I graph these two? What type of functions are they? If I say f of x equals x minus 2 or f of x equals x minus 5, how will I graph them? What are they? Yes. So are they, do they have a positive slope? Then they look like this, from negative to positive. Or if they have a negative slope, then they look like this, from positive to negative. Right. So that's why it's negative before it crosses the x-axis, and it's positive after it crosses the x-axis. So I don't need to plug in numbers, but it's fine if you do. I see 3 subintervals. On the first subinterval, I multiply 2 negatives. What will be the sign of the product? In the middle subinterval, I have 1 negative. What will be the sign of the product? And on the last subinterval, I have no negatives. What will be the sign of the product? Finally, I'm done with the chart. I studied the sign of this expression, and now I go back here. Which sign is less than or equal to 0? I only have 2 signs, and only one of them is less than or equal to 0. Which sign is less than or equal to 0? Negative, right? So this product is negative right here. And that's my solution. So x in the interval 2, 5. Your book uses pretty much the same idea. but they just write the real line. I'm fine if you use that method. It's fine. Okay, let's look at another problem. Can I make one up? Okay, here it is. You want it greater than or equal to 0 since this one was less than or equal to 0. Is that okay? Whatever you want. Okay. Well, this is not polynomial. This is not quadratic. It's polynomial. What is the degree? What is the degree of this? 1. The degree of this. The degree of this. The degree of this. And when I multiply x by x by x by x, what degree do I get? I have 4 factors. Perfect. Good. Since this is already chart ready, I have a product on one side and 0 on the other, I can get the chart going. X is the variable in the problem, but then I have x as the first factor. So the top is always values of x. But since I have 4 factors, I have to write all 4 factors one after the other. So negative x minus 3, x plus 1, x minus 4. And since I don't have enough room for the whole thing, I'm going to say product. Yes, Becky had a question? Becky, you have a question? Okay, which one? Oh, I just made up another problem. No, this is it. We are only asked to determine this, to solve the inequality, and we did. Is that enough? Is that clear? I just made up another problem because I wasn't finding what I was trying to show in the book. So I have 4 factors, so I have to have 4 rows, a row for each factor, another row for the entire product, and the top row with values of x. Now you have to give me the 0 of each factor in ascending order. Which factor is first? So for example, what is the 0 of this? 0. What is the 0 of this? Excellent. What is the 0 of this? Perfect. And what is the 0 of this? 4. So we have to put them in ascending order. What will be the first? Next. 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 That's it. Now we have to establish the 0 for each factor. Where is the 0 for the first factor? Good. Where is the 0 for the second factor? Perfect. Where is the 0 for the next? Where is the 0 for the last? 4. What happens to the product in any of those situations? Yes, it's sufficient for one factor to be 0, for the whole product to be 0. Now, if you want to think in terms of the positive slope, then you will write the sign for these 3 without even thinking. And then the sign for this also without thinking, if you want to think in terms of the slope. So all these 3 will look like this. So they have to come from negative and go positive. But this one will have this situation. Will come from positive and go negative. So what is the sign for the first one, the sequence? What is the sign for the second one? Yes, to negative. And for the last 2? Very good. Now I see on the first subinterval, I see 3 negatives. When I multiply or divide 3 negatives, what is the sign? Perfect. In the next subinterval, I count 4 negatives. When I multiply or divide 4 negatives, I get perfect. In the next subinterval, I count 3 negatives. What is the sign? In the next subinterval, I count 2 negatives. And in the last subinterval, I count a negative. Only now, I look at this. What sign do I pick? Which sign is greater than or equal to 0? So this and this, which means this and this. So then x in the interval, -3, -1, union 0, 4. Does it make sense? Notice that all factors were linear factors. This is very important. Okay, let's choose another problem from the book. Anything you want from 1 through 14. And then we can graph the quadratic function. Any preference? Do I get to choose? Okay, I will choose 14 on page 687. And that is x squared minus 16 times x squared minus 1 less than or equal to 0. Well, these are not linear terms, linear factors yet. But I remember how to factor. So then what will I do? Yes, indeed. So the first one. This is chart ready if you decide to use it. It's a product on one side and 0 on the other. These are not quadratic. That's why we, you mean quadratic inequalities? So quadratic inequalities have only 2 factors. Yes, everything that has more than 2 factors is not quadratic, yes. Yes, we only did one quadratic, just the first one. The other 2 were polynomial. We put more factors in there than just 2. X is the variable in the problem. X plus 4 is the first factor. X minus 4 is the next. X plus 1. X minus 1. And the product. Which numbers go at the top? Which values of x? In ascending order. Yes, Becky? Yes, it's the first one, -4. -1, I agree. Yes, that's it. Where is the 0 for x plus 4? Very good. Where is the 0 for x minus 4? Where is the 0 for x plus 1? And where is the 0 for x minus 1? What happens to the product under -4, -1, 1, and 4? All 0, because every time one of the factors is 0, the product will be 0. Perfect. All of them are the same type. All of them come from negative and go to positive. So that's all you have to do, because they have a positive slope. On the first subinterval, I counted 4 negatives. In the next subinterval, I counted 3 negatives. In the next subinterval, I counted 2 negatives. In the next subinterval, careful, I counted 1 negative. And in the last one, good. Only now I look here and I ask myself, which sign am I looking for? And the answer is I'm looking for a sign that is negative. I see negative in 2 spots, between -4 and -1, and between 1 and 4. So that's how I get the solution, this and this. X in the interval, -4, -1, union 1, 4. If you find an easier method with less writing, I encourage you to use it. Do we need more examples before we graph the quadratic function? One more? Yes? On this one, on the previous one? So in order to solve the inequality, it says this has to be less than or equal to 0. Yes, so this has to be less than or equal to 0. So after I study the sign, I'm asking myself, which sign do I pick? So the answer is negative. So the product is negative here and here. Therefore, I have to choose the x values between -4 and -1 and 1 and 4. Because for these x values, the product is negative. For all the other values of x, the product is positive. Does that answer your question? Okay. Good. Do we need more examples? Okay then. So the last 2 sections, 11.5 and 11.6, deal with graphing quadratic equations. I would like to list all the graphs that we know so far, because this is a new graph and we're going to have to add it to the list. If you remember, some time ago I had a handout on all functions that we discuss in this class, and we have 2 more functions in chapter 12 to look at, actually a total of 3 more functions. So we have a list of functions that we know everything about. Here's the first one, linear, which is this graph or this graph. Second one, absolute value, which is this graph. Now I want you to tell me, what is this graph? Very good, square root. And I want you to tell me, what is this graph? Exactly, cube root. So this is the square root of x, and this is the cube root of x. Very good, excellent. And this is the absolute value. Perfect. We're going to add one more to this list. Becky, are you okay? Yes? Okay. Good. So number 5, quadratic. The graph of a quadratic function is a parabola. The graph is a parabola. Parabola is a graph that is symmetric with respect to the axis of symmetry. Symmetric with respect to the axis of symmetry. Its, I should write, its axis of symmetry. There are 2 possibilities. Here's one, and here's the other. Not both. So a parabola can have a maximum or can have a minimum. And as I mentioned, it's a symmetric graph with respect to this axis of symmetry. This is the axis of symmetry. The vertical line passing, yes, Becky? With respect to its axis of symmetry. Sure. Okay. So this is the axis of symmetry, the vertical line through this point that is called the vertex. No other function has a vertex, just the quadratic. So this point is called maximum, but also vertex. This one is called minimum, but also vertex. A quadratic function can be given to us in two different ways. One way is this, which we know this is the same with the quadratic equation, but it can also be given to us in this form. I will start with this. So both are quadratic equations. Functions. Both are quadratic functions. And I'll explain the second one after we finish with the first one. Ready? I'm going to make up a function, simple one to start with, this. And we're asked to graph it. So the function is x squared plus 6x plus 8, and we're asked to graph this function. First step, the shape. By the shape I mean, does it have a maximum or does it have a minimum? And you should say, but we haven't graphed it yet. How will I know? We know. If the leading coefficient is positive, the parabola has a minimum. If the leading coefficient is negative, the parabola will always have a maximum. So coming back to my graphs here, this is definitely a negative leading coefficient, and this is definitely a positive leading coefficient. So when the parabola has a minimum, the leading coefficient is positive, and when it has a maximum, the leading coefficient is negative. Now, if you ask why, I'll tell you why. If you want to graph the simplest possible quadratic function, which is x squared, you will graph it like this. But if you multiply all coefficients, all the y values by -1, if you want to graph this function, you're going to have to flip it. So that's why a positive leading coefficient will give us this graph, and the negative leading coefficient will give us this graph, which is a maximum. Okay. Step number 2, the vertex. This is the most important point. Where is the vertex for this green function? Where is the 0, 0? Yes. Okay, so we have to determine the vertex for our graph, for this function. Let me remind you, let me write again the quadratic formula here. I want to make a point. This piece is called, can anyone remind us what is this called? B squared minus 4AC? The discriminant. Okay, so that part is taken. Now this part is the x-coordinate of the vertex. I wanted to make a connection. I have a link there. Maybe that will help us remember. The x-coordinate of the vertex is -b/2a. So assuming that this is, I don't know, make up a number. Let's say this is 5. How do I determine the y-coordinate of the vertex? What will I do with 5 in order to determine the y-coordinate? Plug it in. So then the y-coordinate of the vertex will always be f of this number. F of negative b over 2a. Okay, so let's find now the vertex for this function. So negative b over 2a. Can anyone give us b? Perfect. Can anyone give us 2 times a? And the answer is? Very good. So I have the x-coordinate of the vertex. Now I need to determine the y-coordinate of the vertex. And you already told me what to do. You said plug it in. So I'm going to plug in negative 3. So f of negative 3 is negative 3 squared plus 6 times negative 3 and plus 8. So how much is negative 3 squared? 9. How much is 6 times negative 3? And plus 8. So this is 17 minus 18, negative 1. So I have the point called vertex, which in this case is a minimum, negative 3, comma, negative 1. Any questions so far? So the first step was the shape, the second step was the vertex. Now the third step, X-intercepts, and I'm going to put a comma if they exist. What does that mean? Again, does this function have a maximum or a minimum? Minimum. There are 3 possibilities for a minimum. This is one. This is the other. And here's the last one. How many x-intercepts does this function have? None. This one. Right, none. How many does this one have? 1, but as we know, it's a double solution. But I'll say 1. How many does this one have? 2. Does this ring a bell? We looked at something last time with none, 1, or 2. What was that? A discriminant. So what is a discriminant in this case? Positive, negative, or 0?
Negative.
No solutions. No solutions, right? Okay, what about this one? Exactly. And of course, what about this one? Positive, because we have 2 solutions. Good. Now let's look at the vertex for a moment. So the parabola looks like this, right? And what is its minimum value? Can you picture the range of this function? From till what? From negative, that's x is the position. Y is the minimum value. Negative 1 to infinity. Will this function, starting at negative 1 and going to infinity, will it have 1 solution, 2 solutions, or no x-intercepts? Exactly. So they exist. Only because this number on the minimum is negative. If I had negative 3 comma 5, it would have been this situation. If I had negative 3 comma 0, it would have been this situation. But because I have negative 3 comma negative 1, it must be this one. So otherwise I don't want to waste my time. But they exist, so I have to find them. How do I find x-intercepts for any function? For That will be the y-intercept. You want to start with the y-intercept, that's fine too. Y-intercept is when x is 0. Very good. F of 0 is 8. So what is the ordered pair? Good. So let's come back to the x-intercepts. How do I find the x-intercepts? I have to set y equal to 0. So then I have x squared plus 6x plus 8 equals 0. That's why we reviewed factoring before moving into this. It doesn't have to factor, as you know. Solutions don't have to be integers. So the factored form will be, is it okay? The factored form will be x plus 2 times x plus 4. So therefore, there are two solutions. X equals, x equals. Very good. -2 and -4. So then the ordered pairs are very good, and -4, 0. Perfect. Number 5 and number 6 are just words, but they are important. What is the axis of symmetry of this quadratic function? Axis of symmetry. Remember, it's the vertical line passing through -3, -1. What will that be? So it's x. Yes, x equals -3 is the axis of symmetry. The last one is, does this function have a max or a min again? Yes, the minimum value of the function of f of x is, you know it because you already told me the range of this function without even graphing it. So the minimum is -1. Can anyone give us the range? One more time, we haven't even graphed the function and we know the range. So the range is, yes, -1 to infinity. Now, the information that we obtained for this function took us like 10 minutes. It's normally going to take us 2 minutes, but it was the first function. So let's graph it now. I have to start with a vertex. That is a must. So -3, -1. I continue with the axis of symmetry, which is not part of the graph. It will only help me keep the graph in shape because it has to be symmetric with respect to this line. Then I have two x-intercepts, -2, 0, and -4, 0. Notice one thing. I know I have a mistake immediately when I plot these points, and one is 1 unit away from the axis of symmetry and the other one is 2 units away or 3 units away. I know something is wrong. So these points have to be symmetric. If one of them is 1 unit away from the axis of symmetry, the other one has to be 1 unit away on the other side. And the last point is 8, 0. I'm sorry, 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. Try to graph this function without having an acute point at the vertex. Make it as round as possible. You can determine as many ordered pairs as you want. That's all we really need. So this is the graph of f of x, x squared plus 6x plus 8. I want to show you a few things with the graphing calculator when you're ready. Becky, are you caught up? You need something? Okay. So let's go to the, oh, I'm sorry, let me stop this for a second. I passed the 15.